All right, let's kick things off with a slightly provocative question. What does it actually take for hard science to finally swallow a ghost?
Welcome to This Explainer. Today, we're unpacking some absolutely radical ideas from MIT physicist Max Tegmark. We're looking at how the strict boundaries of physics are actively expanding, literally stretching, to include the human mind, artificial intelligence, and even the fundamental geometry of understanding itself.
Here's how we're going to break this down. First, we'll look at how physics is swallowing AI. Then, we'll untangle intelligence versus consciousness. Third, we're going to talk about actually testing subjective experience. Fourth, artificial understanding and goals. And finally, we'll debunk the myth of inevitability.
All right, Section 1. When physics swallows AI.
When Michael Faraday first proposed the idea of invisible electromagnetic fields, his peers ruthlessly mocked him. They basically accused him of believing in unscientific nonsense, in literal ghosts. But look at us today. Electromagnetism is fundamental physics. It's the only thing we actually can physically see. Tegmark points out that studying consciousness and AI is facing this exact same historical resistance right now, from, scientific curmudgeons.
Because here's the thing. Physics is always expanding its boundaries. Think about it. We started out studying the massive macro-scale solar system back in the 1600s. Then in the 1900s, we zoomed way in on atoms and way out to map black holes. And now in the 2020s, that boundary has shifted again to swallow artificial intelligence. And this shift is so undeniable that AI pioneers, Geoffrey Hinton and John Hopfield, just recently won Nobel Prizes in physics for working in this exact domain.
Hopfield, for example, used this brilliant egg carton analogy to prove that AI actually acts like physical memory. Imagine you want to store a memory. It's like taking a marble and dropping it into one of the valleys of an empty egg carton. It perfectly models how neural systems store information in stable energy landscapes. Unlike a standard computer, where you have to fetch a very specific variable from a specific memory address, here, you just give it a prompt. You drop the marble, and it naturally rolls into the closest valley, pulling up the full memory. Physics literally gave us the language to understand this kind of associative memory.
Moving right along to Section 2, Intelligence versus Consciousness. Now this is absolutely crucial. We have got to strictly separate intelligence from consciousness. Intelligence is really just the ability to accomplish a task. It's all about doing. Consciousness, on the other hand, is the internal subjective experience. It's the feeling of doing it. You can totally have intelligence without consciousness, like a facial recognition algorithm quietly crunching millions of numbers. And conversely, you can have consciousness without intelligence. Think about having a vivid dream while you're asleep in bed. You're experiencing a whole rich world while outwardly accomplishing zero tasks. To put that into perspective, think of Galileo dropping a grape and a hazelnut. He could use physics to perfectly calculate their fall, predicting the exact millisecond they'd hit the ground. But his equations couldn't explain why the grape felt soft to the touch and the hazelnut felt hard. It's the exact same situation with an AI running facial recognition. It does incredibly complex math to identify a face, but it doesn't feel any subjective experience of actually seeing that person. It just blindly, brilliantly gets the job done.
Which leads us to Section 3, Testing Subjective Experience.
So, how do we prove consciousness isn't just some philosophical hand-waving? Well, Tegmark envisions this absolutely incredible concrete experiment. Here's how it goes. Step 1. You put on a highly advanced MEG brain scanner. Step 2. A computer running a mathematical theory of consciousness predicts exactly what subjective experience you are having right at that precise moment. And Step 3. You, and only you, act as the ultimate judge. If the machine predicts you're subjectively aware of your own heartbeat and you aren't, boom, the theory goes straight in the garbage. You are literally falsifying a physical theory using your own internal reality.
And this kind of hard physical testing could eventually validate some really bold ideas, like Giulio Tononi's theory of integration. This is the concept that for a unified consciousness to exist, processing systems absolutely must intimately communicate with each other. If the information systems inside a brain, or inside an AI for that matter, are totally disconnected, they're basically acting like parallel universes. They simply cannot form one unified subjective feeling.
All right, Section 4, Artificial Understanding and Goals.
We need to draw a stark line between training a system's behavior through reinforcement feedback and instilling actual internal goals. When major tech companies try to align an AI right now, they're often just punishing bad outputs. Tegmark brilliantly compares this to teaching a serial killer to simply hide their desires so they don't get caught. Obviously, that is entirely different from instilling genuine goals. A genuine goal means the entity actually values something, kind of like a parent teaching a child to intrinsically value human kindness, rather than just faking it to avoid getting put in timeout.
But here's where it gets wild. Even though they might not fully grasp their own goals yet, AI might actually be developing a form of true understanding. It's called the Platonic representation hypothesis. This is the mind-blowing idea that entirely different AI systems independently arrive at the exact same geometric shapes to map out concepts. For instance, researchers asked different AI models to map out royal families, and without ever being explicitly taught what a family is, these systems independently drew identical geometric tree structures in high-dimensional space. Isn't that wild?
Let me give you another really incredible example involving the number 59. Researchers trained an AI on modular arithmetic using 59 abstract points. At first, the system struggled. It was failing. But then, it had a literal eureka moment. The researchers looked under the hood and saw that the AI had independently snapped those 59 points into a perfect geometric circle. It had built its own spatial, structural understanding of the clock-like nature of the math problem, completely on its own.
And finally, Section 5. The myth of inevitability.
So ChatGPT passing the Turing test is obviously a massive milestone, but really it's a canary in the coal mine. It's remarkably similar to Enrico Fermi building the first self-sustaining nuclear reactor inside a Chicago squash court back in 1942. Now, Fermi's tiny reactor wasn't really dangerous by itself, but it terrified physicists. Why? Because it signaled that atomic capabilities were real, and the rest was just engineering. ChatGPT signals that human-level AI capabilities are real. But listen to this. It simply means we have reached a critical fork in the road. It does not mean we're facing a guaranteed apocalypse.
There is this doomer narrative out there claiming that if a technology brings power and money, its creation is 100% inevitable, even if it destroys us. But history proves this is a complete myth. Humanity has consistently, collectively chosen not to build dangerous things. We globally banned human cloning, and we strictly enforced it. Similarly, the world agreed to Richard Nixon's bioweapons ban because, frankly, it just wasn't in our collective interest to create cheap, doomsday weapons.
The takeaway here is that we hold the power. We can enforce boundaries and steer this incredible technology. The public, from your local politicians all the way to the Pope, broadly agrees that we want AI as a highly capable tool. A tool to cure diseases and solve massive problems, not as some uncontrollable master. Since we hold the absolute agency to steer this ship toward global flourishing, the ultimate question I want to leave you with today is this: what future will we choose to build?